The table shows the number of protons, neutrons, and electrons in four different particles, W, X, Y, and Z. This is the table given. Now they are asking which pair represent the atoms of two isotopes of the same element. So we have to search for isotopes. So first, keep in your mind that isotopes have same atomic number or same proton number. The same atomic number means that the number of protons in column first and number of electrons in the last column, they must be same. So in W, we are getting 32 protons and 32 electrons. Similarly, if you come down to Y, you will see that 32 protons are in it and 32 electrons are in it. So it means W and Y are isotopes, and second definition, that isotopes have different number of neutrons. So if you look at W, it has 40 neutrons and Y has 42 neutrons. So they have different neutrons. So the choice is that W and Y, which is matching to choice A. This is the correct choice. Now, if you look at this, what was the concept in this question? The concept was that you have to focus how to find isotopes. So from their basic definition, you can find them. If you see at X, it has 32 protons. W has also 32 protons, and Z, okay. So it means that they are isotopes. No, over here, we are getting 32 electrons, and they never mentioned that it is anion or cation, just given a table to us. So this is why. So the correct choice is choice A. Where in the periodic table is the element that has an outer electron shell arrangement of 4s2 4p3? We are given the valence electron configuration of that element, and we are asked that find its group in the periodic table as well as its period. First of all, period. The highest principal quantum number in the electronic configuration will give us the period of the element in the periodic table. And this quantum number is written before like ns, np, nd, and nf. So the highest quantum number, principal quantum number that we are getting in these, that will give us the period of the element. So in this case, we are given that it has 4s2 and 4p3. So this is, they say that it's outer electron shell, so means that it is valence shell, and it is the highest quantum number, principal quantum number. So this number is 4, means that this element belongs to period 4. So here in period column, we are getting choice B and choice D. Now coming towards the group. In group, there was the older, that group classification was that we were given as group first A, group second A, group third A, and so on. While in transition elements, there was group first B, second B, and third B, etc. But the new recommendation from the IUPAC for for element having electron in S, so the valence electron number will give you the group number. It is for S block elements. For P block elements, there is valence electron plus 10 will give you P block group number of P block. Valence electron, how much valence electron are there? And 10 should be added, so you will get the group. And for D block, valence electron means that is n minus 1d plus ns electron. This will give you the group of D block elements. Now we are giving the S electron 4s2 and 4p3. So for P block, we have to calculate the valence electron plus 10, and the answer will give us the group number. So there are 2 electron in S plus 3 electron in P subshell and plus 10 electron from the formula, and we will get 15. So it belongs to group 15, that is choice D. The group 15, now called, can also be termed as 5th A group because they have 5 electrons in their valence shell, so they are termed as 5th A. And similarly, you will see 5th B. B groups contain transition elements, and A groups contain normal elements or representative elements. But now the new grouping system is that 1, 2, 3 up to 18 group we are getting in the periodic table, continuously or consecutively. Which contains the largest number of hydrogen atoms? Okay, to find the atoms of a particular element in a compound, we will follow with this formula. Atoms is equal to given moles of that substance, n for that mole, multiplied Avogadro's number and multiplied atomicity of that element in the given substance. This formula will help us to find the largest number of hydrogen atoms in the given quantities of the substances. So let's start with choice A, 0.10 mole of pentane. Pentane C5H12. This is the formula of pentane. Now, hydrogen atoms is equal to, given moles, they are 0.10 multiplied Avogadro number, write it just Na, multiplied atomicity. Atomicity of hydrogen in pentane is 12, so multiply 12. So we are getting the answer 1.2 Na atoms of hydrogen in 0.10 mole of pentane. The next one, 0.20 mole of butene. Butene, it is C4H8. Now atoms of hydrogen in it, hydrogen atoms is equal to given moles 0.20 multiplied Avogadro number multiplied atomicity. The atomicity of hydrogen in butene is 8. This will give us 1.6 Avogadro number of atoms of hydrogen. The choice C, 1 mole of hydrogen molecule. Hydrogen is H2 in the form of molecule. Now hydrogen atom in it will be equals to given moles, 1 mole multiplied Avogadro number, and the atomicity is 2 because this molecule is composed of 2 atoms. So we are getting 2 Avogadro number of atoms. In choice D, there are 6.02 into 10 power 23 hydrogen atoms, and this is straightforward 1 mole of hydrogen atoms, that is 1 mole of hydrogen atoms, which is 6.02 into 10 power 23 atoms. Now, the largest number of hydrogen atom is 2 Avogadro number. Means it is 2 multiplied the Avogadro number, 6.02 into 10 power 23. So correct choice is choice C. Element X is in period 3. Element X form a solid oxide Y. Y reacts with hot concentrated hydrochloric acid. Y reacts with hot aqueous sodium hydroxide to form a compound in which X is part of an anion. How many p electron does one atom of X have in its outer shell? Well, the statement is long, but the clue in this question is it is period 3 element. In period 3, we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. The next, it form solid oxide. And when this oxide reacts with hydrochloric acid, it can also react with aqueous sodium hydroxide, means that this Y is amphoteric. This is amphoteric. Now, in period 3, the amphoteric oxide is produced by aluminum only, that is Al2O3. How many p electron does one atom of X have in its outer shell? In this period 3, sodium and magnesium belongs to S block, while the rest of the elements of period 3 are P block. The P subshell starts with aluminum P1, silicon P2, and ends at P6 at argon. So the X is aluminum and it has 1 electron in its P outer shell. This is choice B. When hydrogen iodide is reacted with concentrated sulfuric acid, several reactions occur, including this reaction, which row gives the change in oxidation number of iodine and of sulfur in this reaction. In order to solve this, first of all, we will write the oxidation number of each element in reactant and product, especially the target element, that is iodine and sulfur. In the reactants, iodine over here has -1 oxidation state, and you calculate for sulfur, so you will get +6. How to calculate for sulfur that +6? Let me solve it for you. Look at this, H2SO4. There is no charge on it, so equal to 0. Now, hydrogen has oxidation state of +1 and there are 2 hydrogen. So +1 multiplied 2. We have to find the sulfur. Oxygen are 4 and 1 oxygen has -2 oxidation state equal to 0. This becomes +2 sulfur and this becomes -8 equals to 0. Now move -8 and +2 to the right side. Sulfur is equal to, when +2 move to the right, you will get -2 and -8 will become +8. So you will get +6, the oxidation state of sulfur in H2SO4. In the reactants, in H2S, sulfur has -2 because there are 2 hydrogen and each hydrogen has +1. So for +2 of hydrogens, -2 is sulfur. And in this form, their iodine is now in elemental form. In elemental form, all elements has the oxidation state on number of 0. Now look for the change. Iodine moved from -1 to 0 and sulfur moved from +6 to -2. Now finding the change for iodine. In reactant, it is -1 and in product, it becomes 0. So the change is +1. When -1 and +1, they cancel each other, we will get 0. So +1 is for iodine. So in the choices, we have +1 in choice C and +1 in choice D. Now for sulfur. In reactant, sulfur is +6. And in product, it is -2. Now the change is what? The change over here, if you add -8 to +6, you will get -2. So -8 is the change, and that -8 is in the choice D. So the correct choice is choice D. Which gas would behave most like an ideal gas under room conditions? Okay, ideality of a gas. This is ideality. Is inversely proportional to two factors. One is denoted by A, which is coefficient of attraction in the gas, and the other is denoted by B, that is bigness constant or size of molecule. Both these factors are inversely proportional to the ideality of a gas. If a gas has strong attractive forces, it is less ideal. If a gas has a large molecular size, large molecular volume, it is less ideal. Now they are asking for an ideal gas, means that attractive force constant, the value of A should be the least, and similarly the value of B, size of molecule, should be the smaller. Now looking at the choices, helium is a monoatomic molecule and its atom has a smaller size. Nitrogen is a diatomic molecule and the two atoms are connected by a triple bond. Ammonia NH3 is a triatomic molecule, but it is polar too. And krypton is again a monoatomic molecule with a big size. So helium and nitrogen have only and only forces, they are London dispersion forces in these. Ammonia has hydrogen bonding in it, and krypton has London dispersion forces because nonpolar molecules have London dispersion forces, the only forces operating in them. This means that ammonia has hydrogen bonding, which is strong attractive forces compared to London dispersion forces. So ammonia is not the choice. Yani the most ideal gas in the given choices. Coming towards now London dispersion forces. Remember, London dispersion forces are directly proportional to molecular size. If the molecular size is greater, London dispersion forces are stronger. When the forces are stronger, the gas is less ideal. So krypton has the largest size. Then nitrogen is composed of two atoms, so its molecule size is larger. And helium has the smallest size, so and the least London dispersion forces. So helium will act most like an ideal gas at the room condition. Choice A is the correct choice. Why is the first ionization energy of oxygen less than that of nitrogen? First of all, oxygen and nitrogen belongs to fifth group having atomic number of 7, and oxygen belongs to sixth group of periodic table having atomic number or proton number of 8. Electronic configuration is for nitrogen 1s2, 2s2, and 2p3. For oxygen, it is 1s2, 2s2, and 2p4. Now, finding that why first ionization energy of oxygen is less than that of nitrogen. In choice A, the nitrogen atom has its outer electron in different subshell. So look it over here. Nitrogen has the outer electron in p subshell 2p, and oxygen has its electron in 2p. Both have the same subshells. So this is not the correct choice. The nuclear charge on the oxygen atom is greater than that on the nitrogen atom. So there are 7 positive charges in the nucleus of nitrogen, and there are 8 positive charges in the nucleus of oxygen. So it is true that oxygen has greater nuclear charge, but nuclear charge is directly proportional to ionization energy. So oxygen's ionization energy must be higher than that of nitrogen, but it is not the case. Oxygen has less than that of nitrogen. So this point is not holding here. The oxygen atom has a pair of electrons in one p orbital that repel one another. Now looking this choice. In nitrogen, the p subshell has 3p orbitals, and each orbital is filled with one electron according to Hund's rule, and now all the electrons are unpaired. In oxygen, we will get this configuration 1, 2, 3, and the fourth electron should be paired with any one of these. So this pair repulsion creates one electron to be removed easily from oxygen. So this is the correct choice. The last one, there is more shielding in oxygen atom. No, both atom have same number of shell, so their shielding effect is same. It is not different. So choice C is the correct. What is the minimum mass of oxygen required to ensure the complete combustion of 12 cubic decimeter of propane measured under room conditions? Okay, in order to solve this question, we must have to write balanced chemical equation. This is our first step, balanced chemical equation. Second, mole volume stoichiometry from the balanced chemical equation. And third, converting moles to mass. These 3 steps will help us to find the correct choice. So first of all, oxygen required to ensure the complete combustion, telling you propane. Propane will burn in oxygen. So propane C3H8. This is propane. Burns with oxygen, and all hydrocarbons, when burned with oxygen, they give carbon dioxide and water with heat of combustion. Now balance the equation. We have 3 carbons in the reactant, so put 3 before carbon dioxide is a coefficient in order to get 3 carbon atoms. Now coming towards the hydrogen, there are 8 hydrogen on reactant side and 2 hydrogen on the product side. So we must have to place 4 over here. 2 4s are 8, so 8 hydrogen on the product side. Now come to the oxygen. Here, oxygen in carbon dioxide, 3 2s are 6 oxygen over here, and 4 oxygen in water. So there are total of 10 oxygen in the product side. To get these in the reactant side, there will be multiplied 5. So 2 5s are 10. So this is the balanced chemical equation. Coming towards the mole volume stoichiometry. From here, we see that 1 mole of propane, is burning with 5 mole of oxygen, producing 3 moles of carbon dioxide and 4 mole of water. Now in question, we have to study for oxygen and propane, mass of oxygen and propane. Here we can see that 1 mole of each gas, mole volume conversion, 1 mole of each gas at room temperature and pressure occupies 24 cubic decimeter of volume. So here it is CH38, 1 mole, and it will occupy 24 cubic decimeter. 5 moles of oxygen react with 5 mole of oxygen. Now they are asking that the volume of propane is 12 cubic decimeter. For 12 cubic decimeter, 12 cubic decimeter. If you see, this 24 is halved and we get 12. In the similar way, we will halve the 5. So we will get 2.5 mole of oxygen. Now converting this 2.5 mole of oxygen into mass. So mole mass conversion, we have the formula that mass in gram is equal to given moles multiplied molar mass of that substance. So there are 2.5 moles multiplied molar mass of oxygen. This is O2. So O oxygen atomic mass is 16 and there are 2. So 16 times 2 is 32. So we are getting 32 gram per mole. Now to the final solution. If you displace this point, you will place 10 below. Here 2 5s are 10, 16 2s are 32. The next 5 5s are 25. So we are getting 5 times 16. That becomes 80 gram. So the choice B is the correct choice. Delta H naught 1 is the standard enthalpy of formation of methane. Delta H naught 2 is the standard enthalpy of combustion of carbon. Delta H naught 3 is the standard enthalpy of combustion of hydrogen. And we are given the combustion reaction for methane gas, in which it reacts with oxygen gas, giving us carbon dioxide and water. And the balanced equation is given. Now there is given delta H naught C, which expression is equivalent to delta H naught C. First of all, this is a reaction. Enthalpy of a reaction, this delta H naught C, can be calculated as that delta H naught of the combustion reaction for methane is equal to summation of enthalpy of formation of the products. This is products enthalpy. Let me write delta H for products, minus summation of enthalpies of formation of reactants. This equation will give us our answer. Now, here the products are carbon dioxide, and they say that delta H naught 2 enthalpy combustion of carbon. When carbon solid is burned in oxygen gas, producing carbon dioxide gas, the heat or the enthalpy is represented by delta H naught 2. So this is the enthalpy of formation of carbon dioxide which is present in the products. The next species present in the product is water. And we are given a clue, standard enthalpy of combustion of hydrogen, that is H naught 3. When hydrogen is reacted with oxygen, producing water in liquid form. Oxygen is gas, hydrogen is gas, and we will need half oxygen. Here, the enthalpy of this reaction delta H naught is given as delta H naught 3 according to the question there. So these two were the enthalpies for the products. Now coming towards the reactants. Methane, standard enthalpy of formation of methane, that is delta H naught 1. Methane is formed by burning solid carbon with hydrogen gas, giving us methane gas. So we will put 2 here to balance the equation. Remember, 1 mole of the compound will be formed. So to get 1 mole of the compound, carbon is 1 mole from the start, and hydrogen should be balanced as 2. This enthalpy of formation for methane is 1. The next species in the reactant is oxygen. And remember, all elements, when they are in their standard states, so oxygen gas is in its standard state, they have the enthalpy of formation 0. So now we have all these values here. We will put these values in this equation, and then we will match it to the choices. So coming towards this equation, delta H naught C, I'm writing here, delta H naught C is equal to summation of enthalpies of product. The product is carbon dioxide, and it has enthalpy delta H naught 2. This is delta H naught 2 plus the enthalpy of water, and water has the enthalpy delta H naught 3. But remember, there is 2 molecules of water or 2 moles of water. So we will place 2 here, and delta H naught 3. This will give the summation of enthalpy of products minus summation of enthalpy of reactants. In the reactants, we have methane, and methane's enthalpy is given as delta H naught 1. So we will get delta H naught 1 plus enthalpy of the oxygen, that is 0. So that is 0. Now, the final equation, if we want to choose, that is delta H naught 2 plus 2 delta H naught 3 minus delta H naught 1. So now it is matching to choice D. Delta H naught 2, delta H naught 2, 2 delta H naught 3, 2 delta H naught 3 minus delta H naught 1. So correct choice is choice C. Phosphorus forms 2 chlorides. Phosphorus 3 chloride and is a covalent liquid PCl3, and phosphorus 5 chloride is an ionic solid. One of the ions present is PCl4 positive. What is the shape of PCl3 molecule and the PCl4 positive ion? Again, whisper theory will help us. So first of all, PCl3. Phosphorus is member of fifth group. It has 5 electron in its valence shell. When it bonds with 3 chlorine, so it has this type of bonding nature. Now we are getting one lone pair and 3 bond pairs. In this case, this lone pair will push the bond pair down because the repulsion is different. So we will get phosphorus on the top, and here we will get 3 chlorine like this, giving rise to a pyramidal shape. So this is pyramidal shape. So choice A and B, there are pyramidals. So now we will focus on choice A and choice B. Coming towards PCl4, again, P phosphorus belong to fifth group of the periodic table having 5 valence electrons. Now this is chlorine shared, chlorine shared, chlorine shared. This is PCl3. In PCl4 means that it has shared its one electron with chlorine while the other member of the pair has been lost by it, giving rise to a positive charge on it. Now, if we see there are 4 bond pairs around phosphorus and 4 bond pair presence give rise to a tetrahedral structure. So, phosphorus, it will give us this tetrahedral structure just in this form. So, it has tetrahedral, which is in choice B. So, the correct choice is choice B. In which pair of species do both species have only one unpaired p electron? Well, this question is from the electronic configuration, and we must have to find that there is one p unpaired electron. First of all, p subshell has 3 orbitals. They are px, py, and pz. So we will find and these choices with configuration to have one electron, that is an unpaired electron, or another configuration, any type of p configuration having one unpaired electron. So starting with choice A, argon. Now the question is how I will remember the argon position in the periodic table or its proton number. You will be given a data booklet, but you must have to remember that which element belong to which block of periodic table. The block will help you to find the correct answer. Now argon belongs to p block and it is noble gas. Their electronic configuration is ns2 and np6. Means that argon has np6 configuration. But there is a positive charge on argon, means that it loses an electron. So for argon positive, its p has now 5 electrons. And when we draw the orbital configuration, you will find that there are 3 electrons. This is the fourth one, the fifth one, and here is one unpaired p electron in argon positive. So this is our choice. But now looking to carbon negative, that is a carbonyl. Carbon, this belongs to p block and fourth group of periodic table. They have ns2 and np2 configuration. Now for carbon negative means that it has gained one electron, then we will get ns2 np3 configuration. Now for p orbitals, we will get that each orbital has one electron according to the Hund's rule. So there are 3 unpaired electron in the p subshell, so this is not matching to the choice. Coming towards choice B, that is boron and titanium. Boron belongs to third group of periodic table and their configuration is ns2 np1. Third group means that they have 3 valence electron. Now in boron we will get np1, so the p orbital, there is one unpaired electron in the p orbital, so this is according to the question. Now titanium. Titanium positive. First of all, titanium belongs to D block elements, so we do not need to configure it. If you want to configure it, then you will get titanium has atomic number of 22 and its configuration is ns2 n minus 1 d1. So it has means that it has 4s2 and n minus 1 becomes 3. This n is the principal quantum number. So it is 3d1. When it loses its d electron or s electron, again its p orbital is here, which is 4p having 0 electrons. So it is not in our choice. Fluorine and gallium. Fluorine belongs to 7th group and 7th group elements have 7 electron in their valence shell. that is ns2 and np5. Here, if you look at fluorine, the p5 electrons are distributed in the orbital as 1, 2, 3, 4, and 5th. So there is one unpaired p electron. So fluorine is according to the question. Gallium. Gallium belongs to third A group, again boron family. So gallium has np1 configuration. So np1 configuration means that in the p orbitals there is one electron in the p subshell, and that electron is unpaired. So it is according to our question. So the correct choice is choice C, in which both the species have only one unpaired p electron. Selenium and selenium negative and silicon negative, if you want to configure these, so let me solve these. Selenium is oxygen, sulfur, and selenium. This is sixth group of the periodic table, and they have electronic configuration ns2 and np4. Now, for selenium, it has a negative charge, so means that selenium has np5. And when you draw the orbital configuration, there is three orbital, 1, 2, 3, 4, and 5th. So there is one unpaired p electron. So selenium is according to the question. Now coming towards the silicon negative, this is carbon, silicon, germanium, and tin. These are fourth group elements. They have 4 electron in valence shell, and their configuration is ns2 and np2. For silicon negative, then we will get the p has 3 electron, np3, and when we draw this, we will get 3 unpaired electron in the p orbital. So it is not according to the question. So the correct choice is choice C.